Hello. So let's get started here talking about stars and galaxies. Physics 1403, fall semester 2020. I've already recorded a short introductory video, but let's get started with the regular lectures now. Basically, why do we even bother studying astronomy in the first place? Now, I like astronomy because it's fun. It's interesting. I look up at the sky. I want to know, why is it like that? What are those stars up there? How do they work? And so forth. The sun is a star, and so how does the sun work? And I also like astronomy because there's always something new. I've been teaching this class for a very long time now. First time I started teaching astronomy was back in the mid-1980s. And practically every semester that I teach, it's a little bit different because there's always something new that we discover. We used to not know about any planets other than here in the solar system. Now we know about over 4,000 planets and other stars. And so that totally has changed our understanding of the universe. And that brings up an interesting point. Earth is a planet. It's not just an isolated object in the universe. Earth is a planet in the solar system. There are other things in the solar system. And so that means that what happens in space affects us on Earth. Students often think, hey, astronomy stuff out there, it doesn't affect us here on Earth. Well, the reality does. There's always something new happening in astronomy, and so that something new is always interesting. This is actually a photograph that I took about 3 years ago, actually this week, or last week rather, of a solar eclipse. Okay, just a couple years ago, NASA launched a spacecraft to study the sun up close. Excuse that a little bit. I've got a cat that decides to, whenever I'm talking, he has to start crying. But anyway, we had a spacecraft launched towards the sun, and it's giving us our closest up views of the sun. We'll talk more about this later on in the semester. And another interesting thing here is Earth is not alone in the universe, and there was, in fact, in 2013, an asteroid that was passing very close to Earth, and astronomers had discovered it sometime earlier, and they were watching this thing, and then the same day, another asteroid impacted Earth's atmosphere coming from a direction we weren't even looking. It was towards the sun, so we couldn't see anything in that direction. And it crashed into Russia and exploded with the force of roughly a hydrogen bomb, 500 kilotons of TNT. So that's like a small hydrogen bomb, and 1,500 people were injured. And this was a big deal. And it got a little bit of news attention, but the U.S. media doesn't really cover a lot of news outside the United States. But it did cover this a little bit. But 1,500 people hurt. They didn't know it was there until it hit. This actually was a big deal because that meant that the Russian military actually went to full alert status because, it was like this thing came in, looked like a missile, exploded like a hydrogen bomb, and so, they had to quickly decide if they were under attack or if this was a meteorite of some sort. One of the more recent atomic bomb-sized impacts was actually just last year in the central part of the Caribbean. And so just June of last year, so about a year ago, something plopped down into the Caribbean. And you say, wow, okay, so 2012, a hydrogen bomb size thing, 2019, something atomic bomb size hit. And again, it was like almost no warning, only a few hours warning before this one hit. And so the question is, well, how often do these things happen? And the answer is every couple times a decade. We're starting to realize it's way more frequently than we used to think. So now the question is, when was the most recent near miss? The most recent near miss was an asteroid by the name of 2020 QG, and it passed by Earth August 16th. So we're talking just about a week or so ago, and it missed the surface of the Earth by only 1,800 miles. So that's actually beneath a whole bunch of our satellites. And so this thing came in, and now here's the interesting thing. It came from a direction we weren't looking, and we discovered it right after it passed by. So we didn't even know it was coming, and suddenly it passed by. So you know what all this means? This means that we've got the sky falling. Okay, so the chicken was right. Another thing that happens is that every now and then the sun burps. And the technical term is not burp, but it blows a portion of the outer layers off into space, something called a coronal mass ejection. This can result from a solar flare or from another sort of event on the sun that we'll talk about when we talk about the sun later. And these coronal mass ejections can actually send blobs of high energy plasma across the solar system. When that happens, when it runs into Earth, it can create an event that we call a geomagnetic storm. So what does a geomagnetic storm do? Well, it starts fluctuating the magnetic field of the Earth. It can also disrupt satellite and radio communication. It can also disrupt navigation systems. It can also induce radiation exposure. So 2003, there was a big geomagnetic storm that actually caused anybody in a transatlantic aircraft at the time that this happened to receive between 1 and 200 chest x-rays worth of radiation exposure during the course of the flight. Geomagnetic storms and their events are generally referred to as space weather. So they actually held aircraft, transatlantic planes had not yet taken off. They actually held them on the ground, a ground stop, until the radiation subsided. They did not tell the passengers that they were not flying because it was radioactive. They simply said it's a weather delay, which technically is correct because this is in fact space weather. Back in the 1990s, there was a big geomagnetic storm that up in the Northeast created several days electrical blackout. It also knocked out communications to most of California. California Highway Patrol was completely cut off from communications. Also back last century, there was a ship. There was an autopilot using radio navigation beacons and was in an autopilot where it should not have been on autopilot, but it was, and geomagnetic storm happened, ship went off course, ripped the bottom of it open. It turned out to be a supertanker and spilled oil all over Alaska. And so this was a huge environmental disaster. So that can happen. Back in the 1800s, there was a monster storm called the Carrington event that was so powerful it created so much current going down the brand new telegraph lines that have been posted around the Earth, around the North America rather, that it actually caused them to catch on fire, knocked out communication. Now, a similar sized event would be utterly devastating to civilization as we know it, because that would knock out power lines, and I'm not just talking about knocking out power lines and you send a crew out to fix it. We're talking about the entire country, the major high tension lines knocked down, transformers at substations blown out, transformers at generating stations blown out. Basically, it would knock out the entire electrical grid of the United States, and it would take decades to repair it all. So imagine being without electricity for that long. And you can't say, well, I got a generator, so I'm okay, because the generator needs fuel, and the refiners would be knocked out without electricity. Pumping plants, even the gas pumps at service stations would be knocked out. Pretty much the pumping plants for natural gas would be knocked out as well. Pretty much everything. So basically the end of civilization as we know it. So the question you might ask is, could such a thing happen again? And the answer is, actually it did. 2013, the sun had a similar sized eruption, but the blast of material thrown outwards missed Earth. So just let that sink in for a moment. All right. So that's how significant some of these things can be. And so that is why we care about it, and that's why we want to study astronomy. Related to that, I've already, in my introductory lecture, explained a little bit about the format of the class. We talked about the syllabus, some of the important dates that are in there. The course web page is where you're obviously finding this. This is where the other assignments, some of the computer-based labs, because Distant Nature will be posted there. All the handouts are posted there. Old exams, which you can use as study guides. That's all on the web page. You ought to be familiar with the SI system of units. That is what in the United States we typically call the metric system, though I think that's a silly phrase because metric simply means measuring. And so it's a measuring system. Well, yeah, they're all measuring systems. The chapter 1 of your textbook goes through the units here and what nano means and kilo and mega and milli and so forth. You should know that. Kilo means 1,000, mega means 1,000,000, giga means 1,000,000,000. And so know about the scientific notation, because we're not going to actually just simply go out and say it that way. We'll use scientific notation. Make sure you know how to use scientific notation on your calculator. Otherwise, you're going to have issues. So I would say make sure you're familiar with that and look in the instructions for your calculator how to use scientific notation. Basically, as I said in the preliminary introductory lab, we have 3 tests. We've got a final. Final counts double. You have the option of doing a term paper to take the place of something. We got little short essays, the labs using Stellarium, and then we've got worksheet-based labs, and then extra credit. Again, grading, I just add points up like I already explained. And so I'm just reiterating that. If you didn't watch the introductory lecture, go back and watch that because I explain how I grade everything and how all this works. The other things you're going to need are a calculator. And for some of the outdoor naked eye observations, you need a flashlight. And so if you're using a flashlight, then what you want is a flashlight here that has a red filter to it. And so the red filter turns out to be important because the red light allows you to keep your dark adaptation. Now, how do you get a red filter? You can actually buy a flashlight that comes with little filters, or you can just buy an ordinary flashlight and put some red cellophane or fingernail polish or something over the lens in the front. And so there's several different options to make it red, but the red actually saves you, and in fact, this is the 21st century, so you can actually download an app to your phone called Red Flashlight that turns the screen into a red flashlight. Seriously, it really does help, and I'll say more about the labs in a later video. So that'll hopefully make that a little more sense. Basic plan for the class. We're going to start off talking about stars, okay, and then the basic idea of stars, background here, stars, constellations, what do you see with the naked eye? And then we're going to talk about what are stars, how do they work, how do we know about stars? And then we're going to talk about the sun as an example of a star, and then we're going to talk about how stars die. Finally, along with that, and probably we'll talk about it as stars form, is how do planets form? Because planets are formed as a byproduct of star formation. We end the semester talking about galaxies, large systems, and then cosmology, which is the basic structure of the universe itself. So that's the plan for the class. So that's kind of where we're going with all this.